everyone. My name is Laurel Orr, and I'm a principal engineer at NumberStation, and I'm here to talk to you about our recently released NumberStation SQL models that are all on Hugging Face right now, and really how we're trying to use these models to take a step towards closing this performance gap between open source models and proprietary models with a special emphasis on SQL tasks. So I'm sure you're all aware of the rise of foundation models, and I'm going to pause and just spend a couple minutes really recapping why foundation models are so important, and in particular, why they are changing the game of application development. So what is a foundation model? At the 10,000 foot view, these are very large models trained with what we call self-supervised learning over massive amounts of data. Now, self-supervised learning at its core is using data that's basically inherently or naturally labeled already to train a model. You don't need to have an engineer go and label the data for a task. Now, for language, and in particular for this talk, I'm going to be focusing on language models. The self-supervised task for language training is very simple. It's literally asking the model to predict the next word given a sequence of text, right? So if you had the phrase, the cat jumped out of the blank, the goal when you train these models is to just have it predict what that blank is. Maybe the cat jumped out of a box or a bag. Now, what this really broke open is the fact that now you could scale up your data to massive sizes because you didn't need to go get it labeled, right? And this very simple task is what sort of broke open a lot for language model training. So with this large scale increase of the amount of data that you can train over, we also saw, around the last 5 years, a dramatic increase in the size of the model that was being trained. This was both due to hardware improvements as well as architectural improvements, and among many other things. So the result was you had an exponential increase in the data scale and the model scale with which some of these early foundation models were being trained. Now, what you saw sort of stunningly is that as the size and the data volume increased, you started to get what we called emergent behaviors, also phrased as called in-context learning. And what this meant is that we saw models generalize to a wide variety of tasks with no specific fine-tuning or weight updates to the model. Now, for example, I'm going to give you two very separate tasks here that are all done by the same model. And again, these models are trained to spit out text. So I give it a bunch of text, it's going to spit out more. So what this means is I can now construct what we call a prompt to go and basically tell the model what we want it to do. So on the top, you have a very simple task, which is basically predicting the capital from a country. Now, how you construct this generally is you give the model three separate things. You give it a little description of what you want. So a phrase like get the capital from the country, a couple in context examples or demonstrations of what you want the model to do. You can think of this as a very, very small amount of labeled data that you can use to tell the model kind of what task you want. And then you give it the input that you want it to predict over. And in this case, it's going to give you Ottawa as the capital of Canada. Now, the crazy thing about this in-context learning is that I can use a different prompt with the exact same model, and it's going to be able to do this very different task, and in particular, date reformatting, right? I can have it go and standardize all my dates. And for anyone who has ever been in the data cleaning world, you'll know how sort of date misups and different formatting can cause a lot of issues when it's trying to run, execute queries on the back end, right? So this very simple task can be done by this model as well as a wide variety of other tasks. And this in-context learning was really what was so astounding about these models. So it's worth pausing and reflecting, what do foundation models mean when it comes to AI applications and development? Well, there's really three key pillars that I want to highlight here as being some of the most important reasons why foundation models are changing the game. The first, as I mentioned in the last slide, is that they're fairly taskless models. And by that, I mean, you can encode a different task with a different prompt, and it's the same model in the back end, right? So, whereas a few years ago, you had every single task in a completely separate siloed pipeline that had to have model training and monitoring and evaluation, you now have a much simpler much simpler pipeline because it's all being fed through one model. Now, the second reason is this idea that you don't need labeled data anymore to turn on new tasks. As I saw before, all that you do is literally change the prompt itself. Maybe you're looking at 5 to 20 labeled examples, but you don't need to go and generate an entire training data set to get these separate tasks to turn on, right? So it's really removing this notion of a cold start problem when it comes to turning on and developing tasks. It means you can go prototype your method very, very quickly with foundation models. Now, the last piece is this notion of democratizing access, right? To go and build models before, you basically had to be an ML expert or work with ML experts. They had to understand how to label the data and curate the pipeline and build the model and train it. Now, users can simply program in natural language by describing what they want. So you're seeing people with a wide variety of skill sets now all being able to interact with and develop applications all through the use of foundation models. So how does NumberStation come in, which is the startup that I work for now? And in particular, I want to sort of dive into a little bit about how we're leveraging foundation models to enhance the modern data stack. So at a high level, this is a simplified version of the modern data analytics stack. At the very bottom, you have access to your raw data. This is, account logging or customer purchases. This data usually gets transformed and sent through a pipeline of being integrated with other sources of data, being stored in some kind of global warehouse for the company, being cleaned and transformed, generating and maintaining semantics and business knowledge. And at the very, very top is where actually all the business analytics happens, which is oftentimes done through data insight tools and dashboards like Tableau. Now, communication and making sure all these layers work together is a very tricky problem. As I'll show on the next slide, even just understanding what a user asks and what in terms of what dashboard they want and how to translate that down the stack is fairly complicated. And so the goal of NumberStation is to develop and use foundation model technology to facilitate the process of building dashboards and gaining insights into your data. So to give a very concrete example, suppose you have the data set kind of at the bottom right of this slide, right? It's a very simple example of a customer purchasing status, their payment status, with a different state and an identifier. And let's say there's a business analyst, a BI user, who just wants to understand the distribution of defaulting payments across state. So before foundation models, typically how this was done is the business analyst would go and would interact with the data engineering team. They'd explain what they wanted as this kind of ad hoc query and ask the data engineers to go and construct this query and show it to them as a dashboard. The data engineers would then have to go and iterate back and forth and make sure that the definitions were correct about what defaulting payment meant. They'd have to go and make sure all the pipelines were in place. They'd then have to go and generate the SQL and then go push the dashboard and make sure it was production ready so that the analysts could go interact with it. And this pipeline could take weeks and even in the worst case, months for this business analyst to answer this simple question that they wanted. So with foundation models, what we're trying to do is leverage the fact that these models can understand the question that the user's asking to help them automate this data exploration process. So how you can use a model, and this is a simplified example, is you can actually ask the model, be like, hey, look, here's the data that you could access. Here's the schema of the data. And here's the question that the user wants. You then ask the model to go and generate, in this case, it's SQL queries, which can go and be executed to show a dashboard result to the user. But you're having the model do a lot of the painful work that the data engineer has to do. So in essence, you're building a toolkit here that's going to facilitate this interaction process between the analyst and the engineer. The engineer maybe has to go check the results, but the analyst can start getting insights into their data much more quickly. And so really at the core, what the model is being leveraged to do is to understand the instruction that the user wants and how to translate that, in this case, into a SQL snippet for the user to go and execute to get that result. So at a high level, this is really the grounding use case that I want to use moving forward in this talk is this idea of having a business analyst talk with the model to get this executable piece of code coming out to help them understand their data. Now, I've given you this very simple example and acting like it's all well and good, and this is very simple and straightforward. But as I like to say, prototyping with these models is very easy. Getting them into production is very hard. And so I'm now going to talk about three challenges that we faced that when it comes to actually getting this type of sort of business analytics model deployed and ready to go and actually useful for the business analyst. So the first challenge I want to focus on is this core idea of lack of customization and personalization to the enterprise. A common phrase is that these foundation models are a jack of all trades, but master of none. These models are trained over massive corpuses of web data, so they understand a ton of general knowledge. But when it comes to a specific enterprise, they have no idea what what business analysts mean when they use specific sort of business terminology to ask their questions. And so they oftentimes lack this information and fail to generate the right answer. Right. So as a concrete example, maybe the user says, "Hey, I have this data of properties here. They have the property name, the city, and these two fairly vague attributes in the schema called num, WKO, and neutral." And I can say from experience that this is very common in enterprise data. You get attributes that make sense to some people, but to a common user like me, I have no idea what these attributes mean, and the models don't either. So if the user says, given this schema, what properties have a satisfaction score greater than 75%? If you actually go and feed this query to an available proprietary model online, it'll guess an answer. It makes sense what it guesses, and in this case, it's going to guess that the column neutral is greater than 75. Now, this may seem reasonable, but it's actually completely incorrect and doesn't at all answer what the user wants. If you actually go and interact with a data engineer who understands the required business logic, they'll tell you that the satisfaction score is actually this very specific business metric that's defined as the fraction of this value called num.ko divided by neutral. Right. So the correct query is going to be using this business metric and not just the raw column neutral to get the answer. Right. And so this lack of customization will lead to very incorrect results when it comes to business users asking questions, which can be a catastrophic performance when it comes to actually trying to gain insights into your data. So this is one of the first core challenges that you run into immediately when trying to use foundation models. Now, the second is just more of a general lack of quality in terms of being able to generate the correct code and the correct SQL that's needed to run to execute these queries. So again, these foundation models are very general purpose. They understand every coding language out there, but oftentimes lack these expert skills that are needed to really work for enterprise queries. Right. So, a concrete example of this is if a user asks for a difference in averages looking across city of this neutral score, right? And so if you ask this simply, a model's going to, again, output something that makes sense at a high level, but it's actually incorrect SQL and won't even parse. Right. If you go and talk to these data engineers, these SQL experts, the query itself is going to be much more complicated, right? Often you're looking at nested subqueries and partition clauses and things that most users don't, most average even SQL students don't even know. But it really requires this SQL expertise to be able to execute correctly. And this is also something that you find that the models don't have is they're not experts enough to really tackle the workload that's required by enterprises. So the last challenge I want to highlight is this idea of privacy, right? Enterprises are very hesitant to use these kind of proprietary third-party models that have taken over the Twitter sphere right now, due to privacy concerns. Oftentimes, enterprises have very sensitive information; they can't share it. This data can't, leave their premise or leave their VPN. So if you have a SQL expert or a data engineer or even a business analyst who's trying to ask a question, again, they can't use these kind of third parties, private and proprietary models and, like OpenAI or Anthropic. It's just not going to work for them. The data is too sensitive to leave their VPN. So what enterprises really need is the ability to host these customized models that they own within their VPN so that users can interact with and engage with them. Right. So it's a very straightforward challenge, but a very hard blocker when it comes to actually using foundation models because you have to use ones that can be owned by the enterprise. So how does NumberStation address these three challenges, right? Like our goal was really to take a step and help open the door for enterprises to have models to help business users start to ask and question their questions over their data in a self-service manner. So what I'm going to spend the rest of the time in this talk talking about is this recent release of some of our NumberStation SQL models and the suite of models that we released on Hugging Face, which is really a first step towards addressing these challenges. We have 4 SQL specialized models, which means they are trained specifically over SQL data across a variety of sizes. And you can see on the right as an example of using a kind of this hosted inference that you can get on Hugging Face, you basically give the models the schema that you want. So here's a table called work orders and some information about the attributes there. You give it a little bit of that prompt instruction that I had back in slide 3 or 4, saying, hey, look, give me a SQL query. And then you give them the question, which is how many open work orders are there? How many work orders are open? And the model's going to go ahead and generate a query for you. And so all of our models work this way, but and now I'm going to kind of go into really how this sort of suite of models is again trying to take this first step towards allowing enterprises to really gain access to kind of SQL capabilities of foundation models. So again, that first real issue that I mentioned earlier was this idea of lack of personalization, lack of customizations. Well, the core thing with the NSQL models is that they are on Hugging Face and all with fully permissible licenses for both academic and commercial use. And this was very important for us to not only engage with the open source community, but to also release our model to be fully open so that enterprises had the opportunity to both use the model in production, but also further specialize it if they so desired. They can start training it on their workloads and really getting a model that's useful for them. And so again, all these models are in Hugging Face for immediate sort of use for whatever enterprise or group wants to. So the next challenge was again focus on the fact that these models that general foundation models don't always have the SQL expertise. Well, the NSQL suite of models is trained over, and I'll talk about this in a couple slides in more detail, a large corpus of basically targeted SQL queries and a set of instruction to SQL pairs to help the model really understand SQL dialect and how to answer users' questions in SQL. And so you can see using one of our models that if you, again, ask a slightly more complicated question about open work orders for the largest property, that the model is starting to understand how to join across tables and get nested subqueries and understand more complicated SQL and output correct SQL because we've been able to train it over more SQL data, right? So this means that these models are not going to be useful for anything else other than SQL, but for SQL, they're slowly becoming more and more they're becoming more expert at the task of text to SQL. So the last piece was this idea, this challenge of this ability to host private models, right? So not only, again, as I said earlier, the model's open source, which means that they're allowed to be hosted privately, but we also released a host of different model sizes, right? And the point there was not only for the academic interest in understanding the difference in size and how models perform, but we really wanted to give enterprises the flexibility to use whatever model best met their hardware constraints and latency constraints, right? Typically speaking, as the models get bigger, you're looking at a trade-off between the kinds of hardware that you need to host the models with respect to the latency that you can get and the throughput that you can get, and again, the model size. So you kind of have this complex trade-off space that enterprises need to deal with when they're deciding on what model to host. And so we just wanted to give multiple different sizes and qualities so that enterprises can decide and have a model that can fit their needs. So I'm going to spend the next couple of slides diving a little bit more into the technical details of really how we went about training and developing the data for these NSQL models. And again, I encourage you to reach out afterwards and ask more questions. So at a high level, we actually had a two-phased training approach where we started, as you can see on the far left, with open source pre-trained code models or any models really. Again, we just needed to make sure that they were open and available for use. And so we started from the best backbone that we could, is kind of typically the rule of thumb. And then the first thing that we did was we leveraged the fact that there is a massive wealth of SQL data out on the web that's public. There are numerous GitHub repos that have a ton of just SQL log queries and dumps of SQL from a variety of different databases and backends. Now, this data is kind of messy. It's unstructured. I don't really know what the user was asking. I don't really have the schema, but it's still useful for learning what SQL is and how to write queries. And so we took advantage of this by curating a set of a large dump of SQL queries in kind of a messy form. And we took the model, we first trained it to just generate SQL code. And I literally mean like that next word prediction task that I had on slide 2 about self-supervised learning. We did that here with SQL. We had it predict the next word in the SQL query over this large corpus of text. And so this helped the model understand how to write SQL. It helped it understand certain SQL functions and certain syntax and how to write something that's valid and executable. But that really wasn't good enough for us, actually to deploy these models and use them to start answering users' questions. And so we had to add a second phase of training, which is the one in purple, which is this ability to teach the models to understand what the user is asking. This is the ability to translate from text to SQL. And so for this, we went and we curated a set of text to SQL pairs where we had a question, we had a schema, and then we outputted the exact SQL query that answered the user's question. And so by doing this two-phase training approach, we resulted in models that had a wide variety of a kind of breadth of SQL knowledge, and then were really customized to understand user instructions and how to generate SQLs that address their needs. I'm going to dive into a little bit into that purple data set that we use, that fine-tuning data set, which is, again, also released on Hugging Face. Now, to curate, if anyone's ever been in the SQL, text to SQL world before, there isn't a lot of available data out there that goes from user instruction to SQL. It's actually pretty hard to label this data, as you have to have both the right question, like what's an interesting and valid question that a user would ask, as well as an understanding of what SQL is going to go and give you the right answer. So we spent a lot of time curating this data from about 20 different publicly available sources across the web. And we scraped data from existing benchmarks, from dashboards, from user queries that they asked over data sets that they posted, because we had to make sure that they had the question, the schema, and then the correct SQL. And so at the end, with a couple sort of augmentation tricks to help us sort of diversify and enhance our data, we resulted in about 300,000 samples of text to SQL data to fine tune on. And this is the largest collection of instruction labeled SQL queries, as far as we're aware that exists right now for public use. So again, this is all in Hugging Face. Please go take a look. But this was the data that we used to fine tune all of the models after that pre-training phase. So I'm going to spend the last couple minutes just highlighting the performance of these models, in particular how they're comparing against other open and proprietary models. So to be specific about exactly what models we trained, we took the best open source backbones that we could. So when we first started this effort, we used a lot of the Cogent models by Salesforce. Huge shout out to Salesforce. They've done an amazing job with a lot of their open source models, and their Cogent ones in particular we used for a collection of our models. And then once Llama 2 was released by Meta a month or two ago, we also trained a model over the Llama 2 model that also trained it to do SQL. So again, this is using those two different backbones, we trained our 4 models. So I first want to show a comparison against the NSQL models compared against other open source models. And this is looking at a very common academic data set called Spider. It has a diverse set of questions over about 200 different databases. And then for evaluation purposes, we obviously held out the test set and test databases from all of our evaluations from training so that there's no sort of overlap there. But what you see here is that, especially as the size and quality of the backbone model increases, we start to see that the NSQL models are some of the best open source models for SQL generation tasks compared to the other ones available at the time. Our 6 billion model is even beating a model twice its size when it comes to generating SQL. And so again, this was just a really strong signal to us that specializing a model for SQL was helping sort of push the state of the art for open source models and their ability to generate SQL as well, which was pretty exciting to see. Now, what also mattered was looking at specifically at the comparison against proprietary or private models. And particularly, we looked at OpenAI models. They're some of the most common today. And so we looked at GPT 2.5, which is also the chat GPT model, as well as GPT-4, which is the model in green. And what we see is that here we're really starting to, again, close that performance gap. We saw on the last slide that we're sort of surpassing existing open source models. And now we see that in particular with that Llama model, we're on par with what GPT-4 can perform on this benchmark task, right? So and what this was really exciting to see is that with some data curation effort and the right scoping of a task, you can really start to see open source models beat and even surpass some of these proprietary models. And the real trick there is you have to understand that once you can narrow down the task and have it be an expert in something, that's when you really can start to see some of the wins over these proprietary models, because you can start to get the model to specialize. Right, so that was exciting to see is kind of our closing this performance gap against some of the proprietary models. And the very last sort of thing I want to highlight here is the importance of that two-phase training approach, and why you really need this specialization to occur for these numbers to start to turn on. Right. So the base model here is the backbone model that has been basically is open on Hugging Face and is untouched by any of our number station SQL data, right? So either the Llama 2 model or the Cogent models. And so we start to see that just by pre-training over that kind of raw SQL corpus, you're already seeing a lift, where the models are understanding SQL better, leveraging some of the comments and sort of code snippets that escape into some of the SQL queries to even have a better chance of understanding what a user wants. And then it was really that last phase of instruction tuning where you start to see numbers skyrocket, because it's starting to understand again how to answer a user question and turn it into SQL. So again, both of the training phases are very important, and here just kind of seeing the lift compared to the base models. So I'm just going to end with a massive shout out to all of the open source models and the community there, Hugging Face, Salesforce, and Meta. I mean, they've all done a fantastic job, and I encourage everyone to go and try out the models. We have code, we have data, all available. If you want to learn more about NumberStation, there's a link to our blog there. Thank you so much for taking the time to listen today. If you have any questions, don't hesitate to contact me. My email is on the slide. Yes, again, thank you so much. And this is have fun playing with SQL models. Yeah, thanks.